Hello and welcome. This is Professor Adams. In this video, we're going to go over dividing mixed numbers. By the end of this video, you will have seen a couple of examples of dividing mixed numbers. You will have tried a couple of examples of mixed numbers, and we'll have gone over a couple of applications of the division of mixed numbers. So before we start in on the mixed numbers, why don't we go ahead and have you do these warm-up problems. Put your video on pause, do these warm-up problems, and then come back and check your answers. Welcome back. Let's take a look at the answers. Compare your answers to what I have. Here is 1, 2, and 4. I wanted to talk a little bit about 3 before we moved on. So for number 3, if I have a fraction, say 2/3 divided by, say, 1/5, then I can write this as 2/3 divided by 1/5. Now, when it's in this form, we have a fraction within a fraction. It's a nested fraction, and we're not terribly fond of nested fractions. But I'm allowed to, with an expression or a fraction or a number, I'm allowed to multiply the numerator and the denominator by the same value without changing the overall value of the fraction. That means I can multiply the denominator fraction by 5/1. And I can multiply the numerator fraction by also 5/1. In the denominator fractions, I can see that this 5 and this 5 will cancel in the denominator fractions. So I end up with 2/3 multiplied by 5/1 in the numerator, and then I end up with just 1 in the denominator. So I can write this as 2/3 multiplied by 5/1, which is just 10/3, or as a mixed number, this is 3 and 1/3. Just like when you are multiplying mixed numbers, when you are dividing mixed numbers, you must write the mixed number into its equivalent and proper fraction. And if you are having issues with or having troubles with remembering which one to invert, then you write it in this form. You would write your dividend first, and then you would write your divisor with the division symbol in between. And you can always check your answer, because we know that if we take our divisor, multiply it by the quotient, I'll go back to the dividend. So let's take a look at a couple of examples here. My first example, I have 9 and 1/5 divided by 5 and 3/4. So the first thing I'm going to do is write the equivalent improper fraction. So 5 multiplied by 9, adding 1 more, gives us 46/5. Divided by 4 multiplied by 5, adding 3, is 23/4. Now I'm ready to do the reciprocal or invert the divisor. So 46/5 multiplied by 4/23. I can go ahead and multiply the 46 and the 4 in the numerator and 5 and 23 in the denominator. But if I can reduce before I do the multiplication, I will try to reduce before I do the multiplication. And I see that 23 will go into 23 once, and 23 will go into 46 twice. So what I really have now is I really have 2 multiplied by 4/5 multiplied by 1, which is 8/5. Now I can check this. If I multiply this answer, 8/5, by my divisor, and my divisor is the 23/4, so here's 23/4, I should get back to my dividend. So this is my check, and I'm going to check, and I have same thing. If I can cancel before, I will. So 4 will go into 4 once, 4 goes into 8 twice, and so I have 2 times 23, which gives me 46/5. And there is my dividend. Here's my dividend here, and here's my dividend here with my check. Let's take a look at our second example. Our second example is 7 2/3 divided by 4 1/2. I'm going to rewrite this to make it clear to me which one is the dividend, which one is the divisor, so I remember which is the one that gets inverted or is the reciprocal. So I'm going to write this as 7 2/3 divided by 4 1/2. Now I'm going to write them as their equivalent improper fractions. So I'm going to write 7 2/3 as 23/3 divided by, and I'm going to write 4 1/2 as 9/2. 23/3 multiplied by the reciprocal of the divisor, 2/9. And if I can cancel, I will. In this case, I cannot cancel any numbers. So I'm going to multiply 2 times 23, which gets me 46, and 3 times 9, which is 27. Or, as a mixed number, 1 and 19/27. Now, here's some I'd like you to try. So go ahead and pause your video now. Welcome back. Please check your answers. For my first one, I have 22/9, or 2 4/9. For my second one, I have 28/15, or 1 3/15. For my third one, I have 44/35, or 1 9/35. And then on my last one, I just have 2/3. All right, so let's do some applications of the division of mixed numbers. My first application here, I have a wall I want to build that is 47 1/4 inches high. And I'm going to build it with brick. Each row of brick is 2 5/8 inches high. And that includes the mortar. So I need to know how many rows of brick, not brink, I'm going to need for this particular wall. So I have 47 1/4 divided by, that's the total height of the wall, divided by the height of each row. That's 2 5/8. So I'm going to go ahead and convert these into their improper fractions. So 47 times 4 plus 1 more gives me 189/4. I'm going to do the same thing with 2 5/8, and I have 21/8. Now I'm going to go ahead and multiply by the reciprocal of the divisor, or invert the divisor. So I have 189/4 multiplied by 8/21. Now we know that 4 goes into 4 once, and 4 goes into 8 2 times. And 21 goes into 21 once, and it goes into 189 9 times. So what I have is 9 multiplied by 2/1, or I have 18. And because this is an application, you've got to tell me what those 18 are. They're not 18 bananas. So that's 18 rows of bricks. On this next one, I want you to try it. Give it a go, as the British would say. Go ahead and pause your video right now. So for this one, you have 20 1/2 gallons of water in the holding tank. You're going to divide that by how much each flush of the toilet uses, which is 1 3/5 of a gallon. And you will find out in the holding tank, you can flush 12 3/16 times. In other words, you really have 12 flushes. But that doesn't answer the question. The question asks you, if the toilet is flushed on average 5 times a day, how many days can you go before you need to add water? So if you can do 5 flushes a day, and you get a total of 12 flushes, your final answer is after 2 days, you need to add more water. Thank you for joining me.